Let's begin with the definition of electrolysis. Electrolysis is the process in which, when electric current is passed through a solution of an electrolyte, dissociation or decomposition of an electrolyte takes place, or electrolyte will break up into positive and negative ions. So the definition will be breakdown or decomposition of ionic substance using electric current. What are conductors? You must have clear concept about conductors and electrolytes before proceeding further. Remember, conductors are any solid substance that allows the passage of current or one that conducts electricity. Solid that conducts electricity. Reason is simple, and that is solid contains free or mobile electrons. It contains free or mobile electrons. You can call it delocalized electrons. Delocalized electrons. See these diagrams. These are the diagrams of metals. This is graphite in pencil. They all are good conductors of electricity. Good conductors of electricity. Because of mobile or free electrons. What are non-conductors? Answer is simple, and that is any solid that does not conduct electricity. Solid that does not conduct electricity. They are also known as insulators. Also known as insulators. Non-conductors or insulators does not have any mobile electrons. They don't have mobile or free electrons. Here we have some examples of non-conductors. These are the wood, and we have common and Himalayan salt. Salts. Wood, for woods, the reason is same, that is they don't have mobile or free electron, but for the salts, they have fixed ions. That's why they do not conduct electricity at all. Once these salts are melted, their ions become free, and then they will be able to conduct electricity also. Well, let's talk about electrolytes. What are electrolytes? Electrolytes are liquids that conduct electricity. Liquids that conduct electricity. Here it's due to the presence of free or mobile ions. It is due to the presence of free or mobile ions. You can include molten salts in this class. Beside molten salts, fruit juices, acids, alkalis, and salt solutions also act as electrolytes. Acids, alkali, they are alkali. This is alkali, calcium hydroxide, or lime water. This is acid, sulfuric acid. They also act as electrolytes. So you can easily now define non-electrolytes. They are liquids that does not conduct electricity. They don't conduct electricity. Because they don't have free ions, free or mobile ions. This here we have some examples of pure or battery water. This is pure or battery water. Pure or battery water, also known as distilled water. So we have other examples also, like you can include organic liquids. You have petrol. They don't have any free ions. So that's why they do not conduct electricity.
Welcome to Chain of Qualified Tutors. Unlock your academic potential with expert tutoring, from secondary school to graduation level. Master math, science, English, and more with personalized one-on-one guidance. Call or WhatsApp for a free demo session. We offer on-site and online tuition.
Now I will talk about the electrical devices and circuit symbols. In electrolytic cell, the source of current is cell. It is the source of current. And you see on the right hand side, these are the two cells. Collection of cells are battery. There are positive and negative terminals in battery. Now, positive terminal is represented by a long, thin line, but the negative terminal is represented by short, fat line. This one is battery. In order to start or stop the flow of electricity, there are switches to start, or stop the flow of current. You have switches at home. In the same way, we need switches here. Here are the symbols we will use during electrolysis. You must have knowledge about these because this will help you in the exam whenever they ask you to draw an electrolytic cell with correct circuit symbols. The symbol used for cell, this one is used for the lamp, this one is used for the switch. Bulbs are placed so that we can check whether the current is flowing or not. To check whether the current is flowing or not. If it is lit, then this means that the current is flowing. For instance, in these two cases, current is flowing. But in this case, no current, as it is not lit. It's not glowing. The brightness of light in the bulb also indicates whether there are maximum or minimum ions in the solution. For instance, in case of weak acids and alkalis, the brightness will be dim like this. This one is by weak acids and alkalis. But in case of strong acids and strong alkalis, we have bright light. Strong acids or alkalis. Ammeters are used to measure the amount of current flowing. It is used to measure the amount of current flowing. You will look at the symbol. Symbol A is used for ammeter. For voltmeter, the symbol V is used. This is voltmeter symbol V, and this is the voltmeter. Voltmeters are used to measure the voltage of cells and batteries. To measure the voltage of cells and batteries. Now, plates which carry electricity into the liquid are known as electrodes. Are the plates which carry current, into the liquid. So they are solids, and I've just told you in the beginning of this video that conductors are solids that conducts electricity. In your syllabus, two types of electrodes used. One is inert or inactive, another is active one. Number one, inert electrode like graphite or platinum. Number two, active electrode like copper. Inert electrodes like graphite or platinum can be used. Inert electrodes only provide free electrons, while active electrodes participate chemically during electrolysis. Metals below in the activity or reactivity series like copper, gold, they are included in active electrodes. Cell or battery is the source of electric current. Electrochemical reaction takes place here, which means chemical reaction produces current or electricity. Chemical reaction produces current. Hence, it is known as electrochemical cells. On the other hand, electricity or current decomposes the electrolyte or ionic substance in the electrolytic cell. It is here it's opposite to what's happening in electrochemical cell. That's electrical energy changes into chemical energy. Electrical energy changes into chemical energy. So you can write for electrochemical cells, chemical energy changes into electrical energy. Chemical energy changes into electrical energy. Both types of cells consist of two electrodes connected to an electrolyte and ionically conducting phase. Two electrodes are cathode and anode. The change from electronic current to ionic current and vice versa is always accompanied by oxidation reduction reactions. Both oxidation and reduction takes place here. In electrochemical cell, the reaction occurs spontaneously at the electrodes, and here the cathode is positive and anode is negative. The reaction taking place is spontaneous. What else? We have a cathode positive, anode negative. In case of electrolytic cell, the reaction is not spontaneous. Reaction is not spontaneous. That is, the reaction has to be forced by applying an external electrical current. The reaction has to be forced by applying an external electrical current. In an electrolytic cell, the cathode is negative and anode is positive. If you look at this electrolytic cell, this is the electrolytic cell. This one is cathode and this one is anode. And blue liquid represent the electrolyte. This is the electrolyte. Electrolyte can either be molten liquid or aqueous solution of ionic salt that undergoes electrolysis. Can be molten liquid or aqueous solution of ionic salt. Solution of ionic salt. So at anode, oxidation takes place. At anode, oxidation takes place. Where's the anode? This one is the anode. So you have loss of electron. Loss of electron. On the other hand, reduction takes place at cathode. Reduction takes place at cathode. Here you have gain of electrons. Gain of electron or electrons. Therefore, the reaction in simple electrolytic cell is redox. Therefore, redox takes place in an electrolytic cell. During electrolysis, electrons are conducted from the anode to the cathode through an outside electrical current which can be used. So electron flows in this way. Here we are having electrons. It's anode to cathode. This is anode. This one is cathode. This action can be reversed in an electrolytic cell. That is, charge moves in the solution in the form of ions from cathode to anode. So we have movement of ions, movement of charge in the solution in the form of ion from cathode to anode. So in this way, the whole circuit will complete. Electrochemical cells are used usually as batteries, while electrolytic cells are used for electroplating metals. So electrochemicals are used. Also, the recharging of a rechargeable battery is an electrolytic reaction. So during electrolysis, there's movement of electrons in the external circuit through conductors. Metals, there's loss and gain of electrons at anode and cathode simultaneously, and movement of ions in the electrolyte. So I will write here loss and gain of electrons, loss and gain of electrons at anode and cathode, anode and cathode simultaneously. Movement of ions in the electrolyte, movement of ions in the electrolyte. Electrochemical cells are used usually as batteries, while electrolytic cells are used for electroplating metals. Application of the products formed at the electrode and observation for these products using inert electrodes. Inert electrodes are made up of either platinum or carbon graphite. Both platinum and graphite are best choices for their usage as inert electrode. This is because they have free or mobile electrons. They do not react and have very high melting points. For lead to bromide, you should know the chemical formula of lead to bromide, which is PbBr2. Lead or Pb will carry positive charge and moves toward cathode. So this will be lead ions. They get reduced and discharged as molten lead. You see, you will get molten lead. Molten means it's in the liquid form. You will write silvery white liquid obtained at cathode. Silvery white liquid obtained. This is cathode. And here, gain of electron takes place. At anode, you will write reddish brown fumes. You see these are reddish brown fumes. Reddish brown fumes. obtained. These are of bromine, bromine gas. And here you are getting lead, solid or liquid. For all the metals in their molten state, you will just write silvery white liquid, except copper and gold. For copper, you will write pink or reddish brown liquid, and for gold, it will be either yellow or golden. Bromine exists in reddish brown liquid at room temperature pressure, and it's highly volatile liquid. Due to this reason, you will obtain reddish brown fumes at anode. Sodium chloride. The formula for sodium chloride will be, as you know, NaCl. In this case, sodium ions or Na plus ions will move towards cathode and reduce or gain electrons to get discharged as silvery white sodium liquid. So this will be sodium. Solid or liquid. So at cathode, silvery white liquid obtained. You can even write silvery white solid for metals. Chloride ions will move towards anode, lose electrons or oxidized and discharge as yellow-green gas, which is Cl2. You see, this is chlorine gas. So the observation at anode will be yellowish green gas. Yellowish green gas released. You see here the products obtained are not in their normal state. This is because of high temperature, as we need to heat the ionic salts. Due to this reason, we are getting molten liquids for metals and gases at anode. Zinc iodide. The formula for zinc iodide will be ZnI2. ZnI2. In this case, zinc ion or Zn plus 2 ions will move towards cathode and gain electrons to get discharged as silvery white liquid. This will be zinc solid. Iodide ions will move towards anode and discharge as purple gas, which is I2. Iodine gas. So at cathode, zinc liquid, at anode, iodine gas. Dilute sulfuric acid. Now let's predict the product for the electrolysis of aqueous solutions. There will be two types of solutions in terms of concentration of the acids, alkalis and ionic salts, that is dilute and concentrated solutions. You know that in dilute, the amount or concentration of water is high as compared to the solute present. While in case of concentrated solutions, the concentration of water is low as compared to the solute present. So we have dilute sulfuric acid here, which means the concentration of water is high as compared to the acid present. First of all, you should know both the cation and anions present or produced in the solution. The formula of sulfuric acid is H2SO4. Here there are hydrogen or H positive ions. First I will write ions. H positive or hydrogen ion, hydroxide or OH negative ion, and sulfate or SO4 minus 2 ions. Hydrogen ions will move towards cathode and reduced or gain electrons to produce hydrogen gas. This is hydrogen gas, H2 gas. You see these bubbles, these are of hydrogen gas. On the other hand, both hydroxide and sulfate ions will move towards anode, but only hydroxide ions will lose electrons or oxidized to produce oxygen gas and water. So these are the bubbles of O2 gas at anode. This is because the hydroxide ions are in high concentration as compared to sulfate ions. At cathode, H2 or hydrogen gas. So what will be the observation at cathode? You will write colorless and explosive gas. Colorless and explosive gas obtained. What about anode? You will get O2 or oxygen gas. So you write colorless and odorless gas. Colorless and odorless gas obtained. Dilute sodium hydroxide. The formula of sodium hydroxide is NaOH. So first of all, we will write the formula of sodium hydroxide. In this solution, there are sodium or Na plus ions, hydrogen or H plus ions, and OH negative ions. Dilute solution means both hydrogen and hydroxide ions are in high concentration. Therefore, you'll get hydrogen gas at cathode and oxygen gas at anode. I've already explained the observations at each electrodes, so I'm not going to write again. H2 gas cathode at anode, O2 gas. At cathode, write the observations for hydrogen gas, that is colorless and explosive gas. While at anode, you will write colorless and odorless gas for oxygen gas. Dilute sodium hydroxide. In dilute sodium chloride, we have sodium chloride solution. So you know the formula, that will be NaCl. So first, let us write the ions present in the solution. We'll have Na plus ion, H positive ion, chloride Cl negative ion, and OH negative or hydroxide ions. Dilute solution means both hydrogen and hydroxide ions are in high concentration. Therefore, the hydrogen will move towards cathode and reduce to produce hydrogen gas, while at anode, hydroxide ions will oxidize to produce oxygen gas and water. Here you will get O2 gas. These are O2, and this one is H2 gas. Cathode, H2 gas obtained at anode, O2 gas obtained. Dilute sodium bromide. You can easily predict the products obtained at each electrode. First, let's write the formula for calcium bromide, CaBr2, and the ions in the solution. We have Ca plus 2, H positive, Br negative, and OH negative. So you know the products. We have H2 gas at cathode, O2 gas at anode. I'm not going to write the same statement. So the reason is same. We will write H2 gas because of high concentration of H plus ions. At anode, O2 gas because of high concentration of OH negative ions. For concentrated aqueous solutions, we can easily predict the products at each electrodes, but you have to consider this activity series. This is the activity series. You have to consider this activity series. It is also known as series of selective discharge. All cations or positive ions are in competition with hydrogen ions in solution. But the cations from potassium till aluminum will never get reduced. Potassium till aluminum never get reduced or discharged. Even when their concentration is high in the solution. Instead, hydrogen ions or above, hydrogen ions will get reduced to produce hydrogen gas. H2 gas produced. This is because they are highly reactive than hydrogen ions or above hydrogen in the activity or reactivity series. Right above hydrogen in the activity series. You can even refer these statements for selective discharge. You see these statements, difficulty of discharge or ease of discharge. Difficulty of discharge, ease of discharge. You can write they have high difficulty of discharge or low ease of discharge as compared to hydrogen ions. Reverse arguments are also acceptable here. For instance, you can write hydrogen ion has high ease of discharge and low difficulty of discharge. For zinc and iron, it is zinc and iron. These will get reduced when they are in high concentration. Reduced when in high concentration. So we have simple reason that is that they have high concentration, so they will get reduced. So as compared to hydrogen ions. For anions, sulfate and nitrate ion, sulfate and chloride, bromide, and iodide ions will get oxidized only when their concentration are high in solution. discharged when high concentration. Concentrated sodium chloride. You can easily predict the products at each electrodes. At cathode, only hydrogen is the product. This is just because sodium ions are above hydrogen in the activity series. So I will write H2 gas. First we'll write ions. We have Na plus ion, H positive, Cl negative, and OH negative. At cathode, hydrogen, because Na plus more reactive than H positive ion, or Na positive is above H positive ion in the activity series. On the other hand, chlorine gas will be produced at anode due to its high concentration. These are the bubbles of yellow-green bubbles of chlorine gas. So you write at anode, chlorine gas, because of high concentration of Cl negative ions as compared to OH negative ions. At cathode, the observation will be bubbles of colorless and explosive gas, while at anode there will be bubbles of light yellow gas. Chlorine is yellowish green, greenish yellow gas at room temperature and pressure, but light yellow in water solution. Concentrated nitric acid, HNO3. In case of nitric acid, you know the cations and anions in the solution. So first of all, we write the ions in the solution. We have H positive ion, we have NO3 minus ion, and OH negative ions. Here, definitely there will be hydrogen gas produced at cathode. Hydroxide or OH negative ions, as well as nitrate ions, move towards anode in the solution, but will get oxygen gas. The reason is same. Nitrate ions have low ease of discharge as compared to hydroxide ion. Again, you can also refer to the activity series for nitrate ions. So you write at cathode, then there aren't any reason at cathode we only have H2 gas obtained. You know the observations. I'm not writing the observations at this moment. At anode, I will write O2 gas because of low ease of discharge for NO3 minus ions as compared to OH negative ions. Aqueous copper 2 chloride. The formula of copper 2 chloride will be CuCl2. Here the ions are, so first we'll write the ions, the Cu plus 2, H positive, Cl negative, and OH negative. Copper ions are below hydrogen, so it will always get discharged, whether it's present in high or low concentration. So this one is copper solid. This one is copper solid. So at cathode, reddish brown solid because of high ease of discharge for Cu+2 ions as compared to H positive ions. At anode, it's very easy to identify the product. As you see here, the concentration of chloride ions are high. So there will be bubbles of light yellow chlorine gas, Cl2 gas. At anode, Cl2 gas because of high concentration of Cl negative ions. Now, if you look at this table, we have identified either hydrogen or metal as a product produced at the cathode. So at cathode, metal, solid, or hydrogen gas obtained. And at anode, you will either have oxygen gas or halogens. Oxygen gas or halogen obtained. When the metal ions are in the solution, they will never get reduced because of their position in the activity series, or you can even refer to ease or difficulty of discharge. So these will never discharge or reduced because they have low ease of discharge or high difficulty of discharge. They are above hydrogen, above hydrogen in the activity series. Only these two metals get discharged, reduced, when high in concentration. Metals below hydrogen will get discharged because of their position in the activity series. Always reduced. Either dilute or concentrated. You can easily refer to low difficulty of discharge or high ease of discharge for these metals. Same concept is applicable to anions, sulfate and nitrate. When they are in high or low concentration, they will never get discharged. You can refer to either activity series or series of selective discharge for explanation. That is, they are highly reactive, low ease of discharge, high difficulty of discharge. Only these ions will get released when they are in high concentration. Oxidized when high in concentration. I've also explained the observation for both hydrogen gas and metals. Like there will be bubbles of colorless and explosive gas in case of hydrogen gas. H2 gas, bubbles of explosive and colorless gas. For metals, we'll write silvery white solid for all the metals except copper and gold. Copper, reddish brown or pink solid. Reddish, brown, or pink solid. Gold, we'll write yellow solid. For oxygen gas at anode, there will be bubbles of colorless and odorless gas. Oxygen gas. Bubbles of colorless and odorless gas. So we have different observations for these gases: Br2, bromine, Cl2, chlorine, I2, iodine, chlorine, yellowish green at room temperature pressure. And in solution, it will be light yellow. Bromine, reddish brown at room temperature pressure. And in solution, it will produce orange. Iodine, we have a purple solid or fumes when it's in the gaseous state. Now, what will be the observations in case of source of metals below hydrogen like copper 2 sulfate? Copper ions will get reduced at cathode and will deposit as or discharge as reddish brown or pink solid. So you'll write reddish brown or pink solid. What about silver? You write silvery white. Already explained. Solid. At anode, we will always get oxygen or water because sulfate never get discharged either in dilute or concentrated solution. You can refer activity series or series of selective discharge for reasoning. So you have bubbles of colorless and odorless gas. Here you see reddish brown solid deposit at cathode. Copper solid. Reddish brown copper solid. These are a copper metal and bubbles at anode. So we have oxygen gas, O2 gas at anode. Now, what will happen if you will replace the graphite electrodes with copper electrodes? We have copper electrodes. These two are copper electrodes. We know that copper will deposit at cathode. This time it will gain electron and deposit directly on the cathode. Right here, Cu+2 ions will move towards cathode like this and takes up electron. As a result, cathode will gain in mass. Cathode gain in mass. The copper ions number will decrease in the solution. So in order to compensate this loss, the anode will dissolve. Decrease in mass of anode. Remember, there are other two negative ions in the solution, but they never get discharged because copper anode dissolves to release copper ions. Can you recall those negative ions? We also have sulfate, SO4 minus 2, and OH negative ions. Sulfate and hydroxide will remain in the solution. As a result, the solution will remain blue in color. Remain blue in color. As long as Cu plus 2 ions are there. Now this slide shows that copper cathode increase in size because cathode gain mass. Cu plus 2 deposits. On the other hand, you'll see anode decrease in mass. Cu dissolves to release Cu plus 2 ions in the solution. Zinc iodide. For molten zinc iodide, you know the products, that is molten zinc will be produced at cathode. So at cathode, you will get molten zinc. Silvery white liquid. And purple fumes of iodine gas produced at anode. Iodine gas, and the appearance will be purple fumes. So these are of I2, iodine, and this is zinc. Remember this point that at cathode, there will be a reduction or gain of electrons, which means zinc ions will gain electrons, while at anode, there will be oxidation or loss of electrons, which means iodide ions loses 2 electrons to release iodine gas or fumes. We have reduction at cathode, oxidation at anode. Dilute sodium chloride. Now, in case of dilute sodium chloride solution, we will get hydrogen gas at cathode. This is hydrogen gas. These are the bubbles of hydrogen gas. Because of higher concentration of hydrogen ions in solution, and at anode, we will get oxygen, again due to higher concentration of hydroxide ions. These are O2, bubbles of O2 gas. So write cathode, hydrogen gas. We have bubbles of colorless and explosive gas. Anode, oxygen gas, bubbles of colorless gas. Concentrated sodium chloride. In case of concentrated sodium chloride, we will again get hydrogen gas at cathode instead of sodium metal. This is because although the concentration of sodium ions are high, but sodium is more reactive or above hydrogen. So at cathode, we will write hydrogen gas because Na plus above H positive in the activity series. You can even quote the selective discharge in your answer, like you can write sodium ions have high difficulty of discharge or low ease of discharge, again in comparison with H positive or hydrogen ions. Reverse arguments for hydrogen ions are acceptable here. Chlorine gas will be discharged as yellow-green gas. This is because of higher concentration of chloride ions as compared to hydroxide ions in the solution. So at anode, chlorine gas because of higher concentration of Cl negative ions. Zinc iodide. Now I'm going to explain how to construct ionic half equations for reactions at both electrodes. This one is for molten zinc iodide. You know the formula zinc iodide ZnI2. At cathode, zinc ions will gain 2 electrons like this. Zn plus 2 molten plus 2 electrons Zn molten. So this is Zn molten. You have to write L for the molten ions. At anode, there will be loss of 2 electrons by iodide ions to release purple fumes of iodine molecule like this. I minus, 2I minus, molten, I2 gas plus 2 electrons. So these are I2, purple fumes of I2. Dilute sodium chloride. This one is for aqueous solution. And here we are having dilute solution of sodium chloride. Sodium chloride. You know that due to higher concentration of H positive ions, it will be discharged as hydrogen gas. Therefore, the cathode reaction was gain of 2 electrons by the hydrogen ions. Cathode 2H positive aqueous plus 2 electrons H2 gas. So these are bubbles of H2 gas. At anode, there will be loss of electrons by hydroxide ions to release oxygen gas, water molecules, and 4 moles of electrons. So you write like this: anode OH negative aqueous O2 gas plus 2 H2O liquid plus 4 moles of electrons. 4. So these are the bubbles of O2 gas. Again, it is due to higher concentration of hydroxide ions as compared to chloride ions. Recall gain of electron or electrons is reduction and loss of electrons is oxidation. So reduction takes place at cathode and oxidation takes place at anode. Notice one thing here, and that is you need to write AQ instead of L, which means aqueous. AQ means aqueous or in water. The ions are in water. Concentrated sodium chloride, NaCl Now, what about concentrated sodium chloride? You know that hydrogen gas is produced at cathode and chlorine gas at anode. So these are hydrogen gas. This is Cl2 gas. So cathode reaction will be like this. 2 H positive ions plus 2 electrons, H2 gas, anode, 2 Cl negative aqueous gives Cl2 gas plus 2 electrons. You'll get yellow bubbles of chlorine gas and colorless and explosive bubbles of colorless and explosive gas, that is hydrogen at cathode. Aqueous copper 2 chloride. You know that metals below hydrogen get discharged due to the reason that they have high ease of discharge and low difficulty of discharge as compared to hydrogen ions. So here we will get copper ions gaining electrons at cathode like this. These are copper metal. This one is copper metal and this one is chlorine gas. So at cathode, we have Cu plus 2 aqueous plus 2 electrons. We get Cu solid. The temperature is not high in the solution, it will produce as Cu solid. At anode, chlorine gas is released only if the concentration of chloride ions are high in the solution. So I will write the loss of electrons by chlorine here. Cl negative aqueous 2 moles of chloride ions, we get Cl2 gas plus 2 electrons. Aqueous copper 2 sulfate with copper electrodes. Now, what if we have copper electrodes instead of graphite or carbon electrodes? These are copper electrodes. At cathode, there will be reduction or gain of electrons by copper ions, and you can write reverse form of this reaction at anode. That is, product become reactant and reactant become product. Like this, I'm going to write it at cathode. The gain of electron by copper 2 plus ions, Cu plus 2 aqueous, 2 electrons, you'll get Cu solid. The reverse reaction of this one will be, reverse form will be written at anode, that is Cu solid dissolved to produce Cu plus 2 ions. The reason is that copper electrodes are active and they will participate chemically in the electrolysis. And in order to compensate the loss of Cu plus 2 ions in the solution, copper anode dissolves. This is copper anode dissolves. And there's a increase in mass of cathode. Increase in mass. Cathode. Remember, at cathode there is reduction and at anode there is oxidation. State that metal objects are electroplated to improve their appearance and resistance to corrosion. Electroplating is the process of depositing a layer of desired metal on any other metal, like you can electroplate iron car parts, iron utensils, etc. You know the meaning of electro, that is current, and plating means that act of covering a metal object with a thin layer or coating of a different metal. Why metal objects are electroplated? To improve appearance and resistance to corrosion. To improve appearance and resistance to corrosion. Electrolysis can be used to refine metals. Electrolysis can be used to refine metals. For example, if we have a sample of impure copper that we want to refine, we set up a unique electrolysis cell to do that. The cathode will be made of pure copper. It will be made of pure copper. The anode will be made of impure copper sample. Impure copper sample. The electrolyte will be a solution of a copper salt. Like best you can have copper to sulfate or nitrate. This is electrolyte. The process in which a metal which is likely to corrode is coated with a thin protective coating of a metal. For example, galvanizing of iron. Galvanizing of iron. Like coating with a layer of zinc. Coating with a layer of zinc. Object to be plated is made cathode and the metal we wish to plate is made anode. Electroplating is carried out to enhance metal appearance. To enhance metal appearance. Metal, or you can even say objects appearance. Like to utensils, crockery, prevent corrosion of the metal. It prevent corrosion of the metal. The idea of the electroplating cell is very similar to that of refining. Now I'm going to explain you through label diagram how are you going to solve this past paper question. Question says, I'm writing the question. Draw a labeled diagram to show how a fork made of nickel is electroplated with silver. You must show in your label diagram workable arrangements with two electrodes dipping in liquid. Two electrodes dipping in liquid connected to power supply. Connected to battery or power supply with two wires and no obvious gaps. Nickel or the fork is negative electrode. Nickel or fork is negative electrode, which is cathode. And silver is positive electrodes. Silver is positive electrode. Electrolyte is labeled soluble silver salt or electrolyte. Soluble silver salt, like silver nitrate or silver sulfate. The diagram would be like this. This one will be silver electrode. Short fat line represents cathode. This is the fork. This is silver. Power supply or battery. We have electrolyte. AgNO3 or Ag2SO4. The cathode is made up of nickel fork and anode will be of silver. You must have a salt, preferably nitrate or sulfate of silver as an electrolyte. Battery as the source of current in this.